All right, so now we're working on trig, and trig is comes in handy when we're trying to find the measures of triangles when we're given specific information. We know that um, we talked about finding the sides of triangles, right triangles when I can use the Pythagorean theorem, or I can use my special rules with my 45, 45, 90 or 30, 60, 90 triangles. But trig comes in handy when we only know information about the angles or the sides or a combination of the two. So let's jump in. Trig really means, so trig, it represents triangle, right? And um, the metry part of trigonometry just means measure. So it means triangle measure, okay? And that's exactly what we're doing. We are finding the measures of the specific parts of the triangle, whether it be the angles or the sides. So first we need to name the triangles a certain way in order for us to be able to use these, name the parts of the triangles a certain way in order for us um, to use them in our trig functions. So one thing that's cool is that the hypotenuse doesn't change. That's always the diagonal. It's um, it's it's not going to change. Now, this theta here, this angle that we're referring to, is that depends, or our sides depend on which angle we're referring to. So if I'm referring to this angle right here, the side opposite of that angle is my opposite side. So we label it as opposite. And the side next to the angle is the adjacent side. Adjacent means next to. So hypotenuse is always diagonal. The opposite side is just called opposite, and the adjacent side means next to. Now, when you change the angle, like for example, if I started talking about this angle, then things change, right? The hypotenuse is still the same, that never changes, but my opposite and adjacent sides have flipped. So we're going to get some practice with labeling triangles for their sides. So if I'm given this labeled angle here, 54, I know already that my diagonal is my hypotenuse, and I know my opposite is the one that's opposite of the angle. So we can label it OPP. And my adjacent side is the one that's sitting next to the angle. So that's how we would label it. And these three-letter abbreviations you'll see all the time. So just get in the habit of labeling that way. So again, here's my angle. My diagonal is here's my hypotenuse. Remember, it's always opposite the right angle. The hypotenuse is always opposite the right angle, so that's easy to remember. For my opposite side of my angle, my given angle, this is OPP, and my adjacent would finally be my third side that is next to my angle. Again, my hypotenuse is always my diagonal. If I look opposite of my angle that I'm looking for, that's my opposite. And my third side is adjacent. Good. Again, hypotenuse is diagonal. My opposite angle here, or my opposite side rather, is there. And then that must make my side here my adjacent. So now that we've gotten some practice with those sides, what we're referring to are trig ratios. So when I have my triangle like I do in this diagram here, my theta, which is that, it's like a zero with a line through it, that represents my angle measure, my unknown angle. It's a Greek letter named theta. So now that we know the placements of the angles, or placements of the sides based on the angle you're talking about, based on your reference angle, we can create ratios that represent our sine functions. So our sine, cosine, and tangent are represented this way. So my theta, my sine is my opposite over hypotenuse. My cosine is my adjacent over hypotenuse, and my tangent is opposite over adjacent. So we're going to get some practice with creating these ratios based on the triangles that we're given. But I do want to familiarize you with something that you may already have seen before. The mnemonic device SOHCAHTOA. So SOHCAHTOA. And that tells me that sine is opposite for the O over the hypotenuse, which is H, SOH. And the ka represents cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's where SOHCAHTOA comes from. So what we're going to do is we're going to pick these triangles and we're going to write ratios for each of those triangles. So if I want to write my sine of A, right? I'm looking at this angle here, my sine of A. I know my sine is my opposite over hypotenuse. So my opposite to A was 20, and my hypotenuse is 29. Let's go ahead and label them as well. Opposite, hypotenuse, and this is adjacent. So my opposite over hypotenuse, 20 over 29, leave it that way. My cosine of A, again, is adjacent over hypotenuse. So my adjacent is 21 and my hypotenuse is 29. That's that. And my tangent of A is opposite over adjacent. And my opposite is 20 and my adjacent is 21. Now, in the event that you can simplify your fractions, you should. Now, I'm going to introduce to you how to solve this problem here, but we're not going to go through it. So if I'm given a triangle like this, a 2 and an 8, and I'm missing a side here, well, when I'm missing a side and I don't know the angle measures of the angle, so I can't use special triangles, I'm going to now do the Pythagorean theorem. So I would, do 2 squared plus x squared is equal to 8 squared. When you solve all this out, you're going to be getting x is equal to the square root of 60. So that is your x. And you could actually simplify this to 2 square root of 15. And then from here, you would just use my opposite, hypotenuse, and adjacent sides to create my sine ratios just like before. So you would, sine would be 2 square root 15 over 8. Cosine would be 2 over 8. And tangent would be 2 square root of 15 over 2. And so that's how you go about it. But first, you would have to use the Pythagorean theorem in order to find your missing side. So being able to find being able to choose the proper ratio depends on what information you're given. So in this case, if I know this angle and I know my opposite and I know my hypotenuse, well, I know opposite over hypotenuse must be sine. So I would say sine of theta is equal to 6 over 10, which is also equal to 3 over 5. So I'm just choosing the angle and the ratio that I'm supposed to be working with. In my situation here, I have adjacent and I have my hypotenuse. So adjacent over hypotenuse is cosine. So cosine of theta is equal to 4 over 12, which is equal to 1 over 3. That's that. So we're just finding the ratios between the sides. Similarly, this is a opposite and an adjacent. So that's tangent. Tangent of theta would be 15 over 9.7. And that's how we would go about it. And of course, if you can reduce your fractions, you should. But probably the most important idea is to find the missing sides. So all of the work that we've done so far is just getting us practice with setting up the ratios in the proper way. Now we need to solve for the given sides that we're missing. And we'll need a little bit of calculator work for that. You can use any scientific calculator you can come across, and they should give you the proper calculations. Just make sure that your calculator that you're using is in degrees and not radians. It has to be in degrees because we're working with our angles in degrees. So in our first example, we have our angle here, which is 27, and I have an opposite side and a hypotenuse. So if I were to actually set up this ratio, instead of saying sine of, so it's going to be sine, and instead of saying sine of theta, I would actually say sine of 27, because I know what it is. So sine of 27 is equal to x over 11.6. Now, if you recall, our properties of equality tell us that if I wanted to get rid of division, I have to do the opposite. I have to do multiplication. So if I want to get rid of the 11.6, I'm going to multiply by 11.6. But remember, with my properties of equality, they tell me that if I do something to one side, I also have to do something to the other to keep the equation equal. I can't just change one side, I have to change both sides by the same thing. So I'm going to multiply both sides by 11.6. The beauty of that is these two 11.6s end up canceling each other out, and I'm left with x. I'm left with x, and x is actually equal to 11.6 times the sine of 27. So in your calculator, you can actually input that 11.6 times the sine of 27, and you'd get roughly, approximately 5.3. So what we've found is that this side here is about 5.3. And that's cool. So we knew one side and we knew one angle, and we were able to find one of the missing sides. We could also find the other side, like BC. The problem doesn't ask for that, but we could if we wanted to, right? So that's how you go about doing that. Let's try another example. So if I have my angle here, I have my opposite, and I have my adjacent. So I know that's tangent. So tangent of 67 is equal to x over 7. Well, just like in the previous problem, to get rid of the 7, I would multiply both sides by 7. And x is equal to 7 times the tangent of 67. So when you can put that into your calculator, and you would get approximately 16.5. So 16.5 represents the length of that opposite side there. Now, this problem is actually a little interesting because we're going to get something, we have to do a different step. So if I have my angle here that I'm focused on, I have my hypotenuse, and I have my adjacent. Well, I know that's cosine. Cosine is adjacent over hypotenuse, CAH. So I would set it up like this. I would say cosine of 48 is equal to 11 over x. Now, it's kind of interesting because we have the x on the bottom. Now, there's a really cool way to show how to do this, but I'm going to show you the nice, simple shortcut way. You simply switch the position of the x and the cosine of 48. You can treat these, you can like cross multiply, treat them as fractions, and you would get the same thing, but all we're doing is switching the place of the variable and our trig function. So in this situation, we need to take 11 and divide it by the cosine of 48. Again, you can put that into your calculator. 11 divided by the cosine of 48, and x would roughly be 16.4. So depending on where your variable is, like in these two problems up top, the variable was in the numerator, so we had to get rid of the denominator. Whereas this one, our variable was in the denominator, so we actually had to sort of switch it around in order to calculate. So two different methods based on the situation you're given. So that's our intro into trig functions and how to find them. Next, we're going to talk about finding the missing angles. That's closely related to this.